This is Mrs. Ballard, and this is your video on solving systems by inspection. Solving by inspection. So sometimes we can determine the number of solutions that a system has by simply observing and drawing conclusions from the equations. This is called inspection. So it's like you analyze the equations by looking at them and analyzing them, and not by graphing and not by using substitution. For example, if you know that two lines have the same slope but different y-intercepts, then the system has no solution, or the lines are going to be parallel because like they have the same slope, like that's a line and that's a line. They're tilted the same amount, the same slope, but if this is the y-intercept, then they are crossing that line, the y-intercept, at two different places. So they would be parallel with no solution. Same slope, different y-intercepts. On the other hand, if two equations have the same slope and the same y-intercept, they have infinitely many solutions because they are basically be the same line. One line would be graphed and then the other line would be graphed in the same place. Determine how many solutions each system of equation has. Be sure to explain your thinking in the space provided, and if the system has one solution, solve it. So in taking a look at number 1, it says that y is equal to 1.5x plus 9. The other one, y is equal to 1.5x minus 9. So if I take a look at these slopes are the same. This equation has the same slope, but it has a different y-intercept. So how many solutions is this equation going to have? None. No solutions. Because they are parallel, the lines are parallel. The equations have the same slope but different y-intercepts. On a graph, this would be parallel lines which do not intersect, so it would be no solution. Number 2, now these are not in slope-intercept form, so it's kind of hard for me to tell what the slope is by just looking at them. But if I just reason and take a look at these equations, I'm saying that 7x plus 3y equals 10. That's what one equation says. The other one says that 7x plus 3y equals 30. Is that possible? No. There's no way that I can add up two numbers and get 10 one time and add up two numbers again and get 30. That is not going to happen. So how many solutions does this equation have? None, or no solutions. It's impossible for a number, 7 times a number and 3 times another number to equal 10 and then to equal 30. On a graph, the lines would be parallel. So we would have no solutions or none or no solutions. Same thing. Number 3. When I take a look at these graphs, these equations, I notice that I have different slopes and different y-intercepts. Okay. So that's telling me that I'm going to have one solution. The other thing I could do, of course, is to solve it. I set it up with substitution and solve the equation. So if you take a look, they asked us to solve the solution if it had 1, find the solution. So I got that x equals -1 and y equals 0. So that's the one solution for that equation. Number 4, how many solutions does the system have? Well, I couldn't really figure this out without solving it, because I looked to see this is in slope-intercept form and this one was not. So what I did was I used substitution to solve that. So I substituted the 2x plus 1/2 y into the equation, and I solved it and got 2 equals 2. So I know that that means that I have infinitely many solutions. The other thing that you can do is to get your equation in slope-intercept form. So I changed the second equation to slope-intercept form by adding 8x on both sides and then dividing by 4 on both sides. And that gave me y equals 1/2 x plus 2x, and I rearranged that, and I see that basically I have the same equation. So They are the exact same equation, so they have infinitely many solutions. So let's take a look at and inspect some equations ourselves just by looking at them. I'm going to use my highlighters because I'm just going to be kind of reasoning and taking a look. Got 5 equations here. It says to match each equation on the left with the equation on the right that would make a system with infinitely many solutions. So if the equations have infinitely many solutions, that means that they are the same line. So they're going to have the same slope and the same y-intercept. So let me take a look. If I start with, okay, I know what the slope is here. It's negative 3 over 2x, or negative 3 over 2 is the slope. The y-intercept is 2. So I'm going to look over here and see if I can find another equation that has the same slope and the same y-intercept just by looking at it. Okay, nothing over here has negative 3 over 2. Okay, positive 3 over 2. That's not the same one, letter D. This one has a 3 over 2, but the y is, these are together. Now, if I were to rearrange this, if I subtract 3 over 2x from both sides, then that would give me y equals negative 3 over 2x plus 2. So letter C and number 5 go together. I'm just going to highlight those for now. Taking a look at number 2. Okay, number 2 is in what we call the standard form where the x plus the 3y equals 6 is together there. I'm going to wait and come back to that because I'm going to have to get that in slope-intercept form to see if it has the same slope and the same y-intercept. So I'm going to wait and come back to that. Number 7, y equals 3 over 2x plus 2. So I have a positive 3 over 2 for my slope and a 2 for my y-intercept. Do you see an equation over here that has a positive 3 over 2 for the slope and a 2 for the y-intercept? Yeah, there it is, letter D. Positive 3 over 2, positive 3 over 2, and the y-intercept is 2, y-intercept is 2. Okay. Let's take a look at number 8. Number 8, again, is in standard form. I'm going to need to solve this for y in order to match them up, so I'm going to wait on that one as well, taking a look at it. Number 9, y equals negative 3x plus 6. So if I look over here, do I have something similar? Well, letter B is almost there. What could I do? If I subtract 3x from both sides there, that would give me y equals negative 3x plus 6. So number 9 and B go together. Okay. So let me take a look at number 2. Again, number 2, I'm going to need to rearrange this. So I'm going to subtract 2x from both sides. So that will give me 3y equals 6 minus 2x, and divide by 3. So y would equal 2 minus 2 over 3x. Okay, so if I rearrange that, that gives me y equals negative 2 over 3x plus 2. Do I have a negative 3 over 2x plus 2? I do. There it is right there. So number 6 goes with A. Number 8 must go with E, but let me check it to be sure. I'm going to go ahead and highlight these because they have to go together unless I make a mistake somewhere else. So again, I'm going to add 6x to both sides. So that gives me 3y equals 6x plus 6. And then divide by 3, so that gives me y equals 2x plus 2. Aha! And that is that same equation. So my answer should be C, A, D, E, and B. For the next section, it says, for each equation below, write your own second equation that will make a system with no solution. Then trade papers with a partner and check each other's work. So if a system has no solution, remember that the lines then are parallel. So they have to have the same slope, but a different y-intercept. So for each of these equations, write an equation that has the same slope, but a different y-intercept, and then get a partner to check it. Trade papers with someone, or have me check it. This equation for you, though, I'm going to get it in slope-intercept form for you. Subtract 4x from both sides, and that would give me y equals negative 4x plus 7. So I need an equation that's parallel to negative 4x plus 7. Number 13. The sum of two numbers is 8. Is it possible for the sum of two numbers to also be 10? Why or why not? Well, think about that. If I add up two numbers and they equal 8, can I add up those same two numbers and they equal 10? No. Okay, two numbers cannot add up to the same thing. So that would be no. I don't know if I'm going to call that no solution, but those two numbers are not going to add up to the same thing. The sum of two numbers is 8. Is it possible for the difference of two numbers to also be 8? Why or why not? Well, when I thought about this, I thought, well, if I add up 8 and 0, I get 8. And if I subtract 8 minus 0, I get 8. So yes, that could work. Okay. Summarizing today's lesson. So by looking closely, inspecting equations, we can often tell if they have one solution. If they have one solution, we know they're going to have different slopes. If they have no solution, we know that the slopes are going to be the same and the y-intercepts are going to be different. If they have infinitely many solutions, we know they have the same slopes and the same y-intercepts. Thank you for watching your video. Remember, don't hesitate to see me, ask me if you have any questions.